by two number, destination at destination comma source. And we know that the equation is destination equal to destination plus source. So if you know this, that how we are going to do the addition in assembly language, which is the destination equal to destination plus source. If you know this one, and does it matter if you know this one, does it matter that how, where and how I ask this question? If I ask this question in the written exam, or if I ask you in the question in the oral exam or the viva. So if you know the answer, do you need an extra preparation to answer the same question? That destination equal to destination plus source, do you need an extra preparation? Because it is the same topic. We are going to ask you the same topic from the same syllabus. Why you need extra preparation? Why you need extra time? And for that also, for extra time, for the next week, you know that for the next week, there is no class. From 15 to 21st of August, all the classes is suspended, although 15th August is the holiday. So you have the full 1 week, no class. So I understand some of you have the problem. Okay, in same day we had 3 exams, 4 exams. So it is a problem. Yes, I agree. It is a problem. So if you ask me that, sir, I have an exam in the same day, is it possible to change my date because I have 3 sections? Of course, if it is possible, I will take your exam in another day. Let's say you have the viva, 3 viva in the same day. So if you ask me that, sir, I have 3 viva in the same day, can I give the viva in any other day because we have a viva from 16 to 21. So if I have a time slot of this any of the time, I will also, obviously I will give you, okay, if you have the problem this day, you can come. I have another session on 17, 18, 20, and 21. You can come any one of these dates. So every problem has a solution, but you have to talk to us. Rather than you don't talk to us, don't discuss it and do something else. I know some of the other faculty have some problem. I believe that the problem actually arises for very few selective faculties who are actually creating the problem. We are trying to solve that. So if you still have this kind of problem, let us know. I will personally pursue that and try to solve that problem. But you have to come to me. You have to discuss with us, not me. If you're not comfortable with me, you can talk to any other faculty. They will also do the same. But without doing this, you're just doing something else. This discussion should happen whenever you have the first problem, rather than you missed 1 class. Bottom line is, think logically, right? Think logically. Try to think whatever we have done for you. So if someone had done or did everything for you on the reply, if you do this kind of thing, it is really, really inappropriate. I'm not angry. I'm really, really upset that I have done everything in my IBT life for the students, but on the other side from the students, actually, they don't count it. You don't count it. The affection, the love, the care we did, and we will do in the future, it actually doesn't matter to you at all. That is the sad thing. Doesn't matter to you at all. You only know about the marks. You only know about the grade. Remember one thing. After graduation, you will feel. Now you don't feel it. Now you hate me. It's fine. But after the graduation, everything I'm saying, try to remember. You will feel that after graduation. It happens last 6.5 years. It happens to my personal life as well. I was a student like you as well. In a public university, I know that. So you will feel. In my student life, I also did protest. Not against our university. Not against to my teacher. Against something else. If our teacher come to tell us, do not do this, we didn't do this. Anyway, that's my story. I'm not saying that you have to do the same, but What I'm trying to say is, please respect or at least consider the love, the affection, the care we did, we do, and also we will do. Don't deny it. If you deny it, you can deny, no problem. But if you deny this one, you will not, I mean, on the future or anything else or anywhere else, you actually cannot expect any more thing, right? Anyway, I told you that I'm not angry, I'm a little bit upset, but the relationship with you, the care I mean, already I have shown or I do in the future, it will remain same. Although I'm a little bit upset, but the relationship will be the same. So whenever you have any problem in your rest of your life, you still can come to us, right? Still can come to us, no problem with that. Okay, fine. Any more question? If you feel that SRBD is better than us, it's all right, fine, go. Go and get help from them. Go and get graduated from them, no problem. No problem at all. So sad. Really sad. Anyway, we lost already 30 minutes. If you don't have any problem, please tell me. Otherwise, I start the class. If you have the problem, you are free to go, no problem. By the way, our exam will be 11th of August. That means day before, I mean, day after tomorrow, day after tomorrow, which is 11 Wednesday. And your Viva exam will be, as you have less number of class, so let me take your Viva at the end of the time. That means I think it will be 18. Maybe your Viva will be 18 entire day. I will take Viva entire day from 16, 17, 18, and maybe 21st if I cannot finish this in these 3 days. But this is my Viva day, 16, 17, 18. So for you, that you will have Viva on 18. Other sections like A and your section C, right? Yeah. A and B, they will have 16 and 17. Any problem? Please talk to me. The last half an hour I'm actually talking, which is not right. Yeah. Let me listen from you. That is I just cleared myself. I've just cleared myself, so let me hear from you. Any problem, any clarification, any issues, any request, any protest, anything. One more thing. When I'm in the class, I'm your faculty, I'm your teacher, not your coordinator. Okay? When you come to the campus, when you have any other issues, then I'm your coordinator. When I'm in the class, I'm just a teacher like before, nothing else. So you can talk to me without having any problem or any hesitation. Please.
Sir, as we have class tomorrow, will you gonna take any review class or what?
If we can finish our syllabus, then of course, yes, why not? Because I think we need to still cover multiplication and division, chapter number 7.2. And there will be a question from 7.2. So if we can finish, then we can. Of course, sure. I can suggest you one thing. If you want that you have not finished because you have not covered it. The problem is you can come to my other classes as well tomorrow if you want. If you feel that, okay, you missed one class, if you want to know a little bit more, if you want to learn, or if you want to listen a little bit more, you can come to my other section class, no problem. I don't have class today, anything, but tomorrow I have 3 classes with all 3 sections, like you as well. So if you want, you can come to my other classes. If you want. Just give you any other thing. And one more thing, I'm sorry, where is it? I cannot take exam after 11th of the August because after that we don't have any scheduled class. And we have to take our class on the scheduled day and scheduled class. We cannot take our class exam out of our scheduled class because in this week, 11th, that means Wednesday, that is the last scheduled class with you. That's why we will take the exam on 11th. That's why. Yeah, anything else? No?
Sir,
Yeah.
so what will be the question pattern, or what will be the topic that
Yeah.
will come to the written exam?
Good question. I think I have told you that our exam, written exam and the midterm exams actually is chapter 4, chapter 5, and 7.2. So we don't have any topic in your midterm from first term. So your midterm exam syllabus is chapter 4, chapter 5, and just this 7.2. There will be 5 questions. All of the 5 questions from these 3 chapters. 4, 5, 7.2. 7.2 has only this multiplication and division. Chapter number 5 is only the step which we have already discussed. And chapter number 4 is the entire chapter number 4. How we are going to define addition, subtraction, 4 types of addressing mode, the symbol table, and so many others, multiple definition, all kind of thing. So this is your syllabus for both of the exams. About the Viva question pattern, let me give you an idea. I think we have not finished. We have not discussed about the multiplication. Let me just give a brief, and then I will ask you give you some question about the Viva exam. For example, that whenever you want to do the multiplication in assembly language by using the Pentium processor, we have 3 formats: 8 by 8 bit, 16 by 16. And 32 by 32 bit. That means we can do 8, 16, or 32 bit number, which we can multiply. And both of the number should be in the same size. So both of the numbers should be 8 bit and 8 bit, either 16, 16 or 32, 32. That is the rule. Now the question is, if we want to multiply a 2 bit by 3 bit number, okay, do you think that it's possible? We can multiply 8 bit by 8 bit, 16 bit by 16 bit, and 32 bit by 32 bit. That is the 3 formats we have to do the multiplication in assembly language. But if we want to multiply 2 bit by 3 bit, do you think it's possible?
Maybe not, sir.
Maybe not, sir.
Maybe not. No. It is possible. It is possible in a way that I think you know that you can write a number, or you can convert any number to any number of bits, right? So if you have 2 bits, I think you can convert into the 8 bit, right? By adding some 0, because it is unsigned number, it is positive number. So if you just add some of the 0 on the leftmost side, it can be occupied in an 8 bit, right? Like if you have 111, which is a 3 bit number. So if you want to convert this 111 into 8 bit number, what you need to do? You need to add 50 on the left side, right? Then it is an 8 bit number. Same as the other number, 2 bits number. Let's say you have another number which is 11, 2 bits. So if you want to convert it into the 8 bit, so what you need to do, you need to add 6 more 0 before this 11, and then now it is 8 bit. So now both of the numbers are 8 bit. Now you can easily use this format. Simple, right? So if you know the fact, so this is the fact. This is the fact. I teach you in the class that, okay, there are 3 possible format we have to do the multiplication: 8, 8, 16, 16, and 32, 32. That we have learned. And we have also learned in the class that, yes, it is also possible to other multiplication as well, other number of multiplication. We know that, and I give you the example. That is in the class. Now in the Viva exam, if I ask you that, okay, Mr. something, that let's say, for example, there is a number 7 bit, another number is the 13 bit. I want to multiply a number 7 bit multiplied by 13 bit long number. Do you think it's possible?
Yes, sir.
It is possible,
Yes, sir.
right? All right. So my second question will be in the Viva. Okay, if you understand, or if you say that it is possible, can you tell me how is it possible?
We have to convert it into 16-bit.
Which number?
The both 32-bit.
So both of them.
So your answer is, if you convert both of the number into the 16-bit, then you can multiply the 16-bit number, right? That is your answer, right?
Yes, sir.
Very good. Correct answer.
Yes,
Full marks. So this kind of question can be asked in the Viva. Do you think it is that much difficult? Do you think you'll feel much mental pressure to answer this question? No, right? This type of question will come or will be asked in the Viva. So if you know the fact, the thing is, if you know how to do the multiplication, doesn't matter what type of question I ask, doesn't matter how I ask. If you know the fact, if you know how to do the multiplication by two number in assembly language, so there will be no problem whatsoever if I ask any question related to this multiplication. And it is the same about all the topics. If you know how to do the division, same thing. If you know there is in the division, we also have three formats: divided by 8-bit, divided by 16-bit, divided by 32 bits. If you know the fact, or if you know that how we are going to divide two numbers and where you are going to say, so it doesn't matter how I ask you the question, either it's in the written exam or Viva exam or whatever it is, you can answer it. Should not have any problem. Right? So that's what actually I'm trying to say last half an hour, that it is not a problem for you to do the Viva if you know the fact, if you study a little bit, or if you just attentive in the class, it is quite enough. Okay, so don't be afraid and don't think otherwise. Okay, please. So, any question?
Sir, from chapter 5, stack,
Yeah.
we have learned how we arrange the numbers or
Yeah, how you insert, how you delete. Yes. Yes.
pop, this type things.
Yeah,
So,
yeah.
sir, in theory exam, written exam, what type of question came from this chapter, sir?
It is actually, let me show you. I know it's a common question, but what type of question will come? If I tell you that what type of question will come, it's actually discussing about the question, which is really not correct. So
Actually, sir, I want to know.
Let's say, for example, do you know how we can add it in a stack? You know,
Yes,
right?
sir. Yes,
do
sir.
you know how we can delete from a stack?
Yes, sir.
Like push and pop, right? So that is the topic, right? That is the topic we have learned, that how you insert the data, how you delete the data, push and pop in this picture, and in this picture actually by considering little endian byte ordering, right? Little endian byte ordering, right? So if you know the facts, it doesn't matter how the question is, because if I explain how the question is, then I already give you the question, which is not right. So
only these things, sir, nothing else.
We also have discussed,
how to add, how to delete, or how it arrange, only these things.
Yes.
Okay,
and also some theoretical thing, that what is a stack, right?
Okay.
What is a stack? What is the, how we actually, the basic about the stack. We have also discussed that there are two scenarios. We have like underflow and overflow. We have discussed there are some features. These are the features we have discussed also, right? We have also discussed theoretical thing about the implementation. There are 3 implementation of the stack. That is also we have discussed. So these are the topics.
Yes, sir. I understand, sir.
Okay. So again, I'm telling you the same. If you know the topic we have discussed, if you are understood, don't worry about the type of the question. It's actually, you will be able to answer it. I will not ask any question which we did not discuss in the class, which is not in the book. Maybe you cannot find directly from the book, all right? But if you know the fact, if you know how it works, very easy to answer the question, either in the written or in the Viva or whatever it is. Fine, okay. Any other question? Let me just try to finish it very quickly. About if you don't have any other issue or any other problem, let me complete it very quickly. We already know that in this chapter, which is 7.2. Yeah, anyone want to say something?
So
Sir, there will be questions from the first term exam also?
No,
in our
no.
Viva?
No.
Okay, thank you, sir.
No question, or it is not included in the first term, not in the written or not in the theory exam. Okay, all right. So in this chapter number 7, what is it? No electricity. Okay. So to do the multiplication, very briefly, let me explain it because we don't have that much time. Very briefly, how we are going to do the multiplication. We need to consider two issues whenever we do the multiplication. First issue is very simple. If you want to multiply n bit by n bit, n means any number, n bit by n bit, our result will be always 2n bit long. Okay, multiplying 2n bits values produces a 2n bit result. That means if you are multiplying 8 bit by 8 bit, your result will be 16 bit maximum. If you are multiplying 16, your result will be maximum 32 bits. If you multiply 32, your maximum result size will be 64 bit long. That we need to consider before we do the multiplication, because we have to save it somewhere, right? So that is one issue. Another issue is the signed or unsigned number. Very important one. Sorry. Which is, look at these two examples very quickly. This is all 1 in 8 bit and that is all 1 in 8 bit as well. What do you think about what is the value of this? Of course, it is 255, right? In decimal number, 11111 in 8 bit and 11111 in 8 bit. So we are multiplying 255 into 255 if they are unsigned number. Unsigned number means we are not considering any plus or minus. We are just getting the values of this number. So it is 255, and this is the result if this is unsigned. But if we consider that these are the signed number, that means either it can be positive or negative based on the number, then what you can see that this 111 is actually, you can see that same number, same digits. But if we consider that it's a signed number, then this number represents -1 in decimal, not 255. Question is how? That is the answer, how. If we remember that how we are going to do the negative, positive to negative number, this is the process. This is our 1 in 8 bit. So if you want to convert this positive 1 into the negative 1, what we do, so we convert them, the reverse one and then +1, and then we'll have this. So this is the -1. This is the value for the -1 of this +1 number. So that means all 1 here in 8 bit is now representing -1 in decimal, not 255, same as the second number. So we are now multiplying -1 with another -1. That means, of course, the result is +1. Look at the difference. Same digits we are multiplying, but the result is completely different because this one we consider as unsigned number, this one we consider as signed number. And look at the difference. We need to consider this. We need to consider this whether we are considering it as signed number or unsigned number. Fine. So how do you know that? We will know that by writing the code. Whenever you write the instruction, how the processor will know. The question is how the processor will know that this is a -1 or 255, because all the digits are same. How the processor will know that this is -1 and this is 255? By your code. If you write MUL and then the source, then the processor will understand, okay, this code is for unsigned number. In that case, this is 255. But if you write IMUL, which is this one, the code is a little bit different, this one, IMUL, integer multiplication, then the processor will assume that, okay, this is IMUL you have written, that means this number is a signed number. In that case, this is -1 instead of 255. So according to your code, the processor will identify either it's a signed number or unsigned number. Fine? Do you understand? Any question? Until if you understand this until this point, the multiplication is super easy. All right, so we have to consider two things. One is our result should be 2n-bit long, and our I should have a consideration that either it's an unsigned or signed number. If you consider these two, multiplication is very simple. So if you understand up to this, very good, then we can go to the code. So easy, as you can see that the code is very simple. MUL, the source means any register or any memory address, but it is not possible to write an immediate addressing mode like this, like direct value. It is not possible. That's why it's so invalid. So the question is now that we are multiplying two numbers, but we are writing in the code one number or source of one number. Where is the other number? The answer is, if your source, that we consider that this is a source. So if your source is 8-bit long, we consider that other number is stored into the AL register, which is an accumulator. If you remember chapter number 3, type of register, there are 4 types of data register, and that is the first type, EAX, right? Remember the EAX, the top one in the EAX is 32-bit, AX is the 16-bit, and AL and AH is the 8-bit. So that is the accumulator and that is the AL. That means that if our source, or if we want to multiply, is 8-bit, then we use AL register. If our source is 16-bit long, then we consider that our other number is stored into the AX register, which is 16-bit long. If our source is 32-bit long, right, we consider that our number is stored, other number is stored into the EAX register. All right, for example, we want to multiply 10 and 25, just for example. So we move the value into the AL, because what is the reason? Because the 10 or 25, obviously, it is possible to store it into the 8-bit register, right? Into the 8-bit register. So it is very simple that we can convert this 10 decimal number into the 8-bit AL register. If it is more than 255, then we are going to use it, the 16-bit register, right? But here it is this 10 is very small number, so it's very easy to accommodate into the 8-bit. So we move into the AL register, we move into the DL register, another one, and then you write the code, multiply DL. Whenever you write multiply DL, that means actually multiply AL multiplied by DL, because we consider that our DL, that means our source, DL is our source. Our source is 8-bit long. I mean, we can convert it into the 8-bit. So our other register will be AL. That's how we can do the multiplication. That is another example. We want to multiply 10 into 26. If you want to, let's say, for example, we want to multiply 260. We want to multiply 260 with 225. Then what will happen? 260 is not possible to store into AL register because 260 value requires 9 bits, but AL is 8 bits. In that case, obviously, we're going to use 16 by 16 register. I mean, multiplication of that means we need to store 260 into the AX register, instead of AL. Then we do the multiplication of AX and DX if our source is DX. So it depends on the number. Also, we choose which format is suitable for that multiplication. Fine? Any question?
Sir, when it will be EAX?
EAX, when your value, your source is 32-bit wrong. Let's say you have a big number. Let's say 25,000. Your source, you want to multiply 25,000 with 25,000. Then what will happen? Do you think that 25,000 can be stored into the AX register? No. Then you have used the EAX. So depends on the number. Depends on the number. If you cannot fit that number into the 16-bit or into the 8-bit, obviously you're going to use the 32-bit, right?
Yes, sir.
That is the solution. So depend on the number, depend on the situation, you will choose. You need to choose which format you are going to use to do the multiplication. By the way, I think you know that in the video, I mean in the YouTube, there this full explanation there. I think I'm not sure about there's a division as well, but check the video. I cannot remember. So if you still have, because we don't have time, we might have another class and I have to go to the campus as well. So so if you feel any problem, you can watch those videos. You can read the book because the book is written very, very easily. If you just read through it, it is super easy to understand. If you understand until this point, I hope and I believe that you can understand the rest of the part as well. Because as I said, that we have very short time, we have only one class left, which is tomorrow. And if you want, you can come to the other classes. For example, tomorrow, Tuesday, I think in the morning and in the afternoon classes, I think I will go for the revision. So if anyone wants to come to those classes, you are welcome. Any more problem?
You told that 8-bit with 8-bit, 16-bit, 16-bit, and 32-bit with 32-bit. So, sir, if our first number is 32-bit, that means it will be in EX, and second number is 8-bit.
Yeah.
I mean.
So, what do you think? What do you think? Is it possible to multiply 32-bit multiplied by 8-bit? It is possible.
No, sir. But how you will
How
convert
did you
it,
convert from 3-bit to 8-bit?
Sir, by adding
how
0.
You're going to do that? Same way, right?
Okay, sir.
Same thing, right?
Yes, sir.
So it's actually basic thing are same. So any situation you have, the basic things are same.
Sir, I have a question, sir.
Sure. Hurry up. We have.
But in here, in multi ML, sir, can you please show the code? MUL, then
source. Source means.
But how it connect with L? There is no mention about L.
Because I told you, Look at the format. We assume that if your source is 8-bit, we assume that other number is in the AL that is fixed. That means whenever you write this code, MUL DL is actually meaning that AL multiplied
if there
by DL.
Any other 8-bit
if it is 8-bit, it is always AL. AL multiplied by the source if it is 8-bit.
So is it possible if there are more than one 8-bit register?
No, we always use the accumulator register. Accumulator register is AL, AX, and EAX. These are fixed. If you remember that our accumulator register is data register 1, these are all fixed. So it depends on your source. If your source is different, instead of DL, if you use CL, still it will be AL multiplied by CL. If you write a DX, right? If your source is DX, so multiply DX means AX multiplied by DX. Okay? These are all fixed. AL, AX, EX, these are all fixed. Right?
Yes, sir.
Okay, let me give you the attendance. If you still have any other problem, let me know. Let me give you that image very quickly. Section C, today is 9, 10, 1, 2. All right, please respond. Shakil Ahmed. Mominur Rahman.
Present, sir.
Saidul Islam.
Yes, sir.
Moinul Islam.
Yes, sir.
Emil Sharkar.
Yes, sir.
Shahriar Haq.
Yes, sir.
Khadim Haq Rani. Mukit Hassan. Said Mukitul Islam. Shabujur Rahman.
Yes, sir.
Vikon Kumar Das.
Present, sir.
Mit Hassan.
Present, sir.
Rubel Babu. Rizwan Ahmed.
Present, sir.
Jannat Naim.
Yes, sir.
Imtiaz Tasnim.
Yes, sir.
Tahira Ahmed.
Present, sir.
Sadia Akhtar.
Yes, sir.
Afia Siddiqa.
Yes, sir.
Rahul Devnath.
Yes, sir. Yes, sir.
Abdul Sabur.
Present, sir.
Rohanul Kabir. Rubayat Alam.
Yes, sir.
Samuel Rudro. Lamia Akhtar.
Yes, sir.
Sumaya Islam.
Yes, sir.
Abir Hussain. Fahim bin Shahid. Muhammad Mahabub Alam.
Yes, sir.
Mihura Akhtar Mim.
Yes, sir.
Shin Tasnim.
Present, yes.
Yamiul Islam.
Yes, sir.
Daria Shimon.
Present, sir.
Tushar Gop. Ashikur Rahman. Jannatul Firdaus.
Yes, sir.
Tahmina Nasrin.
Yes, sir.
Tahmidur Rahman.
Yes, sir.
Rukaya Jannat.
Yes, sir.
Rakibul Hassan.
Yes, sir.
Sabiha Parvin.
Yes, sir.
Mehdi Hassan Shaju. Al Amin Akash. And Abdul Salam.
Yes, sir.
Okay. Anyone else? Okay. Thank you very much, all of you. See you in the next class. Thank you very